Hey, it's Dave here. In this video, I'll show you how to take any dumb IR controlled device and make it smart using an ESP32 board and ESPHome. By the end of this video, you'll be able to clone the remote of any existing IR controlled device, whether that's a TV, a light or air conditioning, via an IR remote, and control it through Home Assistant. We'll look at cloning remotes, creating buttons, and setting up some real-world automations to get you started. All the code used in this video will be shared on GitHub, link in the description, so let's get to it. Before we get into the code, let's talk about what you need for this project. For the hardware, you've got two options. The first is the simple all-in-one route, an ESP32 dev board and a combined IR transmitter and receiver module. No soldering required, you just need a few female to female jumper cables to connect the pins, plug it in and you're ready to go. For this option, the receiver connects to GPIO27 and the transmitter connects to GPIO26. The wiring diagram for this is on screen now and linked in the description. The second option is a DIY build using individual components, an ESP32, IR LEDs, a transistor, resistors and an IR receiver diode. I've gone ahead and put this together myself, applying my terrible soldering skills, and designed a 3D printed enclosure for this version. Again, the receiver connects to GPIO27 and the transmitter connects to GPIO26, but the wiring is a little bit more involved. The full diagram is on screen now and everything you need, including the 3D printed files, is linked in the description. The good news is the ESPHome code works identical for both options since they use the same GPIO pins, so whichever route you choose, the rest of this video applies to you. Once you've got your hardware wired up, let's head over to ESPHome and flash the board. So from my GitHub repo, I shared the following code. Starting from here, you've got device setup template, and this is just the bare bones where you've flashed your ESP32 board, given it a name, but it doesn't really do anything other than that. I've also tried to somewhat section it because you'll see these particular parts here. You can then add your remote receiver settings, remote transmitter settings, binary sensor, and so on. And if I just scroll down a little bit further, I've sectioned all those different parts that you can copy different bits of the code. So you've got the remote receiver here, along with the code. You'll need to change the GPIO pin, and you may need to set inverted to true or false, along with the mode input true, and pull up true. This particular part here, dump set to all, that means it's going to receive all of the log information. So I'd leave it like that. As I scroll down a little bit further, you've got remote receiver settings, and what I've done is copied all of the different dump settings so you can filter them down later if you need to. This will make more sense once I've flashed the board. I got most of those dump settings from this page here, and what I've done is filtered it out so it's only the infrared settings opposed to the infrared and the RF settings. All of these settings for remote receiver are actually default, but you're going to want to copy them anyway. And if I just scroll down a little bit further, I've then got the remote transmitter settings. Again, you're going to need to set your GPIO pin. And then for binary sensors, I've set up this code just to enable a connection status. You'll need to make sure this goes under binary_sensor:. And if I just go down a bit further, I've done the same for the buttons. I've created a built-in button just to restart the device. And the rest of the button templates is based on the infrared code that your receiver is getting. So for example, if it was Samsung, it will need to look like this one. NEC will look like this, and so on. And if I just scroll down to the bottom, this part is the full IR setup template, including everything above apart from the custom buttons based on your infrared data. And as I scroll down further, you can see I've also included the dump codes as well. And then you've got the remote transmitter, the binary sensor connection status, and the built-in button. So if I just scroll back up, I'm going to copy that part of the code, and then we're going to head over to ESPHome. From ESPHome Builder, we're going to select New Device, select Continue, select New Device Setup, and I'm just going to give it a name, IR Hub Lounge, then click Next. I'm using a standard ESP32 board, so I'm going to select that top choice. And from here, I'm going to click Skip instead of Install. And you can see I've got the device showing here. I'm now going to click Edit. And that code I copied earlier from my GitHub channel, I'm just going to paste in some of the values that have already been generated by ESPHome, such as the name, the API key, the over-the-air password, the Wi-Fi details, which I'm using a secret, along with the access point, SSID, and password. So I'm just going to split this page into two so you can see what's going on. So on the left, I've got the ESPHome code, and on the right, I've got the code I copied from GitHub. So I'm just going to start off by changing this value first. So I'm just going to copy and overwrite this. For the board type, it's actually already correct, but I'm just going to copy and paste it so it looks a little bit cleaner. Depending on what board you selected, this might be different, so I'd also overwrite it. Then I'm going to copy the encryption key and overwrite that value. Next is the over-the-air password. The Wi-Fi SSID, I'm using a secret, so I don't need to specify that. And I've just got this access point to do now. So I'm just going to overwrite that. Now I'm going to scroll down, and there's going to be the parts where I need to reference the GPIO pin. In my example, I'm using GPIO 27. And if I just scroll down a bit further, I'm going to look for remote transmitter. And in my example, I'm using GPIO 26. So I'm just going to overwrite that. The binary sensor and the built-in button, I'm going to leave as it is. So I'm now going to copy all of that code. I'm going to overwrite all of this. Now I'm going to click Save, select Install, and because this is the first time I'm flashing and a device is plugged into my computer, I'll have to select the second option, which is plug into this computer. This is going to take a significant amount of time depending on your machine. It might take a couple minutes. Some people reported it can take a bit longer because it's having to compile all of the code. Now's a good time to take a coffee break while this is happening. Once that's finished compiling, you should have this window, and we're going to select Download Project, and you'll get some sort of a pop-up around here of the bin file. Now we're going to click on ESPHome Web, select Connect, and then select the relevant COM port. In my example, I know it's COM port 4, then click Connect, and we're going to choose Install instead of Prepare for first time use because we've already generated the bin file. Then I'm going to browse to the Downloads folder and open that file. Click Install, and you may need to press the boot button, otherwise it just gets stuck at connecting. In my case, I wasn't quick enough. I'm just going to press the boot button and retry again. That's better. As soon as it says erasing, it's usually going to work. Once that's finished, we can then click close, and we can also close that ESPHome web page as well. And I'm just going to click on that X. Now we're going to go into settings and devices, and we're going to find that new device and let ESPHome take control. So if we go into settings, devices and services, and that's looking good. I can see IR Hub Lounge. So I'm going to click add, select submit, and I'm going to leave the area as lounge, which is where it will be. Click skip and finish. And now you can see I've got that restart button, and I've also got that binary sensor status, which is showing connected. If I just go back a step, you can find it from devices and services. Type in ESPHome, and you should see it somewhere here. Now the board is flashed and connected to Home Assistant, we're going to move on to cloning our existing remotes. But before we start scanning remotes, there's something worth knowing. If you have a Samsung TV that came with two remotes, a standard one and a slim smart remote, you'll find the smart remote doesn't work with our IR receiver. That's because Samsung smart remotes communicate via Bluetooth rather than infrared, so our receiver simply can't see them. Stick to the standard remotes for scanning. Similarly, if you're using an Amazon Fire Stick or Fire Cube remote, you'll find that only some of the buttons work, like the volume controls. The navigation buttons and other controls communicate via Bluetooth, so again, our receiver won't pick those up. Right, let's jump into Home Assistant and open the ESPHome logs. From Home Assistant, if you go into ESPHome Builder, and I'm just going to find my device, which is this one here, and I'm going to select Logs. And what's going to happen is on my Samsung remote, as I press the volume up button, I should see some data coming through, which is looking good. And you'll notice there's quite a lot of information, and not all of it you actually need. So you've got this particular section here where it's got this Pronto data along with this code. And you've also got this one here where it's got Samsung, which is a little bit cleaner, and it's got the data and the n bits equals 32. For this example, that's the value I'm going to be using, because at the moment, if I just press the volume up again, or I press the volume down, it starts getting a bit messy, even though it's only this particular section that I'm actually needing to look for. It'd be nice to filter it so it only shows that particular part of the code. So what we're going to do now is go back into Edit. And this is the part where you're going to thank me, because as I scroll down, and you've got this section here where it says dump equals all, we're actually going to comment that out. So if I press the hash button, and now this section where it's got dump, we're just going to delete that comment, which will also correct the indentation. And I'm going to look for a part where it says Samsung, which is this part here. And now what it's going to do is it's only going to show the Samsung infrared codes. So you may find if you've got perhaps a JVZ remote, you might use this one. Or maybe if you've got an LG remote, or you might want to include multiple devices from this list by simply just deleting the comment. So I'm just going to reflash the device. So I'm just going to click on Save, Install. This time I can select wirelessly and just wait for it to compile and reflash. Now that I've applied that filter and reflashed the board, I'm going to press the volume up and volume down button on my Samsung remote. And now you can see it's much, much cleaner as I press those keys, because it's only showing the Samsung data opposed to all that extra info, which just adds too much noise, especially when you're going through all those manual steps of mapping every single button on your remote. Hopefully that will make your process a little bit easier when you're going through these steps. Now, before I go any further, if ESPHome doesn't recognize the device and it shows it exclusively in raw data, if I just head over to this web page, this is what the logs might show if it's reading raw data. And if I just scroll down a little bit further, it's then giving you the example code when you're adding a button and you're specifically specifying the raw data, which is this part of the code here. I don't have a live example because all of the IR remotes I've been using actually show a model, but I have on my GitHub channel, if I just scroll down, I've referenced the button template if you do need to input raw data. So you can use this here, or if you just go to this web page, and I've referenced it there as well. Back into the logs, I'm now going to start pressing some of the remote control buttons, and I'm then going to map them into a button in ESPHome. What you might want to do is have Notepad or something open so you can start copying and writing these values down as you go along. So I'm going to press the volume up button on my remote, and I'm going to copy this value here, and maybe just call it, and then we're going to do the same. Now I'm going to press volume down, repeat the same, and just copy that value, paste it into Notepad, and just repeat it for all of the buttons that you're wanting to clone on your remote control. Once you've done that, we're going to go into Edit. And if we just go to the buttons section of the code, which is right at the bottom, and I'm just going to paste in some examples I found earlier. So I've got the volume up button, volume down button, channel up, channel down, and I've also got a power toggle. But one of the problems with TV remotes is they don't have a power off button or a power on button, but there is such an infrared signal for power on or power off instead of toggle. And the way I found this is actually just by asking ChatGPT. I just simply copied in this piece of code and I just said, I've got a Samsung remote control. I'm trying to find the power on code. Can you help me? And what it did is it listed a series of websites where you may be able to find them. And it actually took me directly to a Home Assistant forum page where someone had already solved the problem for me, which is this page here. And if I just scroll down, you can see someone's already listed the power off and the power on, which is extremely useful. So back into ESPHome, I'm now going to paste those values, which are these ones here. So you've got, that's the data for power on, and that's the data for power off. I'm now going to reflash that board so I can then see those buttons. So if I click on install, again, it's going to be wireless, and then choose wirelessly, and then just wait for it to reflash. Once that's finished flashing, I'm just going to click stop to close that window. And I'm now going to go back into settings and devices and services. Look for ESPHome, and then find that device. And now you can see under controls, I've now got a list of buttons. So Home Assistant is now able to control my TV. And if I just click on one of these buttons here and then go to settings, I've got the entity ID. So if I want to start creating an automation to press one of these buttons, I now can. Or perhaps you might want to add these buttons to your dashboard. Now that we've got some basic buttons set up, let me show you a couple of more advanced examples to demonstrate just how powerful this can be. First up, we're going to create a timer button, something that would be really useful for air conditioning. This idea is simple. You press one button and it turns the device on and automatically turns it off after a set amount of time. Also added a slider button so you can choose how long the timer runs for, anywhere from 5 minutes up to 2 hours. I don't actually have air conditioning to demo this, but the codes is all there for GitHub and it works with any IR controlled device. Then I want to show you something a bit clever for controlling light brightness. My IR remote has a brightness up and a brightness down button, but there's no way to jump straight to a specific brightness level like 60% or 80%. This reminds me of how a 3D printer homes its axis. It zeroes out X and Y positions first, so it always knows exactly where it is, then moves a precise number of steps to reach a specific point on the bed. I've used the exact same approach here. I know from the maximum brightness, pressing the brightness button down exactly 2 times gets me to around 80%, and 5 times gets me to around 60%. So each preset button sends the brightness command up enough times to guarantee maximum brightness, and then counts down the exact number of presses to hit the target level. Now let's start with the air conditioning timer button first. From Home Assistant, if you go into ESPHome Builder, and I'm just going to find that device, click on Edit. So I'm just going to scroll down and overwrite a chunk of this code. Everything from binary sensor, I'm just going to delete. And if I just scroll back up, I've added these globals, and this part here is just a variable for the AC timer running. You've got this one, which is AC timer remaining, which will set the initial value to 0. I've then created this number, which is going to turn into a slider bar called AC timer, and it's going to have the minimum value of 5 minutes, the maximum value of 120 minutes, which is 2 hours. It will move up and down in increments of 5 steps, and the initial value is going to be 30 minutes. Then I've got this text sensor, which is just going to be an entity called AC timer status, and that will just tell you how many minutes remaining on the timer. For binary sensor, this one's like the previous. Status is just the connection status. This one here called AC status, it's going to show you whether the air conditioning is on or off. And then for this interval, you will need to change some of this to reflect your air conditioning, which is this particular section here. Now in this demo, I'm just using transmit neck as an example, and here would be the code to turn off your AC. What this is doing is running every 60 seconds in a loop to calculate how much time is remaining for the AC, and then once it's eventually ran out, it's going to turn off the air conditioning. One minor limitation with this, let's just say you've set your air conditioning for 30 minutes, and then you're just about to press the button so it will then run for 30 minutes. If this interval at the time was on 30 seconds, then it's actually going to be running for 29 minutes and 30 seconds because the 60-second interval doesn't reset at the time that you press the button. It's not a massive big deal and you probably wouldn't have noticed, but it just means that when you set a timer, the first minute will be slightly off, and then after that, the minutes will be accurate. If I just scroll down to buttons, the restart button just restarts the ESP32 board. Then you've got an AC on button. You will need to change these commands to reflect turning on your AC. You've then got the AC off button, and you will need to find your AC off commands to put here. And I've set this so that when you turn the AC off, if the timer was running, it will automatically reset and go back to 0 minutes remaining. And this last bit, which is here, is an extra button called AC on with timer. So when you have used the slider bar and you've set it for perhaps 25 minutes, and then you press this button, it's then going to run for 25 minutes and then eventually it will turn off. Now I'm just going to save changes and flash the firmware. So if I click install, choose wirelessly, and then just wait for it to recompile and flash the board. Once that's finished flashing, I'm then going to click stop and go into settings, devices and services. and do a search for ESPHome, and then just find that device. And now you can see I've got AC off, AC on with timer. There's a slider bar here, and you've got this sensor, AC status is currently unknown, and you've got AC timer, which is currently unknown. But as I change the values, they're going to change as well. So I'm just going to put AC on, and you can see it's got AC status is on, and then I can turn it to off. And it will also reset the timer to off. And I'm also going to adjust the AC timer. So let's just slide it to 60 minutes. And at the moment, it's got AC status off, AC timer status off. Now, when I press AC on with timer, you can see it's got 60 minutes remaining. And if I decide to turn it off now and press the AC off button, it resets the timer and turns it off. Right, let's move on to setting up the brightness percentage buttons for my lights. From Home Assistant, if you go back into ESPHome Builder, and then just find that device, click Edit, and I'm just going to overwrite another chunk of code. So I'm going to remove these globals and below, and then overwrite. So from the top, you've got the restart button, which just restarts the ESP32 board. I've got a brightness up button, and you will need to change this particular part for your brightness up code. I've got a brightness down button, which does the opposite along with the code here. But as I scroll down, now using a little bit of imagination and tinkering, this lounge light 20% button is going to press the brightness down button 20 times with a delay of 100 milliseconds. If it was at the maximum brightness, you only actually need to press it 12 times, but I've just made it 20, so it just caters for any signal losses. The rest of them get a little bit more complicated. So when you start on this one here, which is light 40% brightness, the way it's going to work is it's going to set the brightness to the maximum, which is this particular part here, and it's going to press it 20 times with a wait time of 100 milliseconds to guarantee it's at 100% brightness. Then there's going to be a half a second pause, and this time it's going to press the down button 8 times, but with a wait time of 200 milliseconds. When I was playing around with this, it didn't always work, and I've also added command repeats, and I've set that to 3. So what it's going to do is essentially send that command 3 times at the same time to just guarantee it's got that code, because it was almost as if when I sent the signal, it wasn't quick enough for it to register. So that seems to be the sweet spot where it's essentially pressing it 8 times with a 200 millisecond delay, but using command repeat 3. As I scroll down, the rest is more or less the same strategy. So lounge light 60%, it starts off, it does exactly the same. It gets it to the highest brightness first, so it's guaranteed at 100%. And this time it's going to press the brightness down button 5 times. And then you've got the last two, light brightness 80%. I probably don't need to explain myself because you already know it's exactly the same as the above. The only thing I'm changing is how many times it's going to press the down button. And then for the final one, when it goes to 100%, I'm just simply telling it to press the button 20 times. And that just guarantees it's going to hit 100% because it only actually needs to press the button 12 times. But if I just say press it 20 times, it counts again for signal loss. Now I'm going to save it and flash wirelessly and wait for it to compile and flash the board. Once that's finished flashing, I'm going to stop and then go to Settings, Devices and Services, and then go into ESPHome. Find that device. And you can see here I've got the brightness down, brightness up, and I've got the percentage buttons below, lounge light 20, 40, 60, 80, and 100. I'm now going to transition to split screen where I can show myself pressing the buttons and show that the lightness is going to a certain percentage. It's quite possible on the camera you may or may not be able to see the brightness going up or down clearly, but we'll see how it comes out. Now this is the remote control I use to control the lights. However, when I press this and try to make the dimming go down, it doesn't actually do anything. You have to really aim directly at the light in order for it to work. So now it is actually dimming. And now I'm just going to put it back to 100% brightness. Now that's going to cause a bit of a limitation because when I'm using my DIY transmitters, they also have to be quite close to that light. And the off-the-shelf one, which I bought from Amazon, which is just the all-in-one transmitter and receiver, it literally has to be about 1 meter away for it to work. Where the one I've got here, where I've got all the parts individually and made my own, that does work from that location. But if I had it somewhere like over here, it's not going to work. So I'm going to demonstrate both of them controlling that light, and you'll see that this one is a little bit better than the all-in-one Amazon version that I purchased. So this is a demo of the transmitter where I put all the components individually together. So I'm just going to press the brightness down. You may or may not be able to see this from the camera, but the brightness is now turning down as I press the button, and I'm just going to manually press it up. So now I'm going to press the 20% brightness button. And what that would do is just keep pressing the brightness down until eventually it gets to the minimum. The one which is a bit more complicated is the 40, 60 and 80%. So I'm just going to press the 80% one. That's going to bring it up to the maximum brightness, and then it's going to go down a few notches to get it to about 80% brightness. I'm just going to go back up to 100%. I'm going to select 40%. You may not be able to see this from the camera, but we'll see what happens. So it sends a command to go to 100%, which it already is, and it is gradually going down a little bit. I can see visually from my eyes in real time, but you may or may not be able to see it on the camera. I'm now going to demonstrate the all-in-one send receiver, which you can see already it has to be extremely close to the light to the point where it's a bit of a failed solution. But I'm just going to press the brightness down button. So the brightness has gone down. You may or may not be able to see this on the camera, and I'm just going to bring it up to the maximum brightness. And I'm just going to send the brightness 40%. This might fail because this particular transmitter is nowhere near as good. So it will send the command to 100%, which it already is, and then it should start going down a few steps. It does seem to have worked. I'm just going to send the command to 60% this time. So it should go a little bit brighter, and then it was slightly dim. That's very hard even to my eyes to see if that worked. So if you are going to play around with these, you really want to either get the individual components so you've got slightly more power, or if there is an off-the-shelf solution where it's a proper all-in-one that is reliable, maybe go down that route. But the DIY version I've made, where I've made all the components, is considerably stronger and more reliable. Now that you understand how to create buttons, instead of showing you how to build a virtual IR remote to use on your phone, let's be realistic. If you've got a physical remote in your hand, you're always going to reach for that over unlocking your phone, opening an app, and navigating to a dashboard. So instead, I want to show you what Home Assistant can do that your physical remote simply can't. I'm going to create 2 automations, one that automatically turns the TV off when I leave home, and the other that mutes the TV when my doorbell rings. These are the kind of set and forget automations that makes your smart home actually feel smart. Let's jump into Home Assistant and set these up. From Home Assistant, if you go into Settings, Automations and Scenes, and then select Create Automation, Create New Automation, And if we just click on those three dots here and select Edit in YAML. And now I'm just going to paste in this example code. Starting from the top, you've got these two triggers. The first one is when the doorbell button is pressed or the flat buzzer is pressed. It's going to set the trigger ID to the value of 1. And the second one is when my state changes from home for greater than 2 minutes, it's going to set the trigger ID to 2. I purposely set it to 2 minutes because sometimes the phone might go into an unknown state. So this just irons out any issues if it briefly lost connection. And then if condition 1 is triggered, it's going to use the button press command and it's going to mute the TV. I've set this, it won't repeat until another 5 minutes because that way, if someone kept continuously pressing the doorbell button, it won't trigger the automation over and over. It will only work once every 5 minutes. Then you've got this second condition, which is this one, which is when the state of the person changes from home. And what it's going to do is use action press button, and then it will turn off the TV. So that way, if I leave my flat after 2 minutes, it will automatically send the TV off command. And mode single just means that if any of the triggers are activated while the automation is already running, they will just be ignored. I'm just going to quickly update those values to real values. And if I just click on these three dots before I save it and select Edit in Visual Editor, you've then got a visual representation of how the automation runs. So the when value are the triggers. So again, you've got the when the hall or front doorbell is pressed, or you've got the other one when Dave changes from home for greater than 2 minutes. And then you've got this choose between two options. So trigger 1 is when the doorbell or flat buzzer is pressed, and it's going to press the button to mute the TV with no repeats for 5 minutes. And then option 2 is when my state changes from home for greater than 2 minutes, it's going to turn off the TV. So now I'm going to save those changes, leave the name as it is and select rename. And now that automation is set up. So there you have it. You've built your own IR hub with ESPHome, cloned your existing remote, and should now be able to create buttons and automations limited only by your imagination. If you enjoyed this video and found it helpful, smash the like button and subscribe. And let me know in the comments if you'd like to see a follow-up video doing the reverse, where I use an old spare IR remote to trigger Home Assistant automations to control smart devices directly. Just a reminder that all the code used in this video is available in GitHub, link in the description. Thanks for watching, and I'll see you in the next one. Bye for now.